in functions, we normally start with composite functions in AS. Now, what are composite functions? For suppose if I say fx is equal to 2x plus 3 and gx is equal to 4x plus 5, and we are told to find f gx. Now, fgx, what does this mean? This means that gx function is substituted in fx. Now, we know that fx is 2x plus 3. If we say f, and let's say gx. Now, this particular gx means that this has been substituted in this particular x. So, if this is substituted, so we are going to substitute gx function, which is 4x plus 5, in the place of x, and then solve. So, your fgx will be 8x plus 10 plus 3. So fgx is equal to 8x plus 13. Okay. So now let's just work on gfx. So if the question would have said gfx, so what does this mean? This means that fx is substituted in gx. So that means gx was 4x plus 5. So if we just write down g and fx in place of x, so that means in place of x, what we can write down is 2x plus 3. And plus 5 will be there as it is there in the function of gx. So gfx will be what? 8x, 4, 3 is 12 plus 5. So gfx becomes 8x plus 17. Now, these are the two normal questions that the examiner will test you in functions of AS. It is also tested in ADMAX. Now, considering that we have been doing composite function, let me just give an example. So here's the example question, that is fx is equal to 6 minus x, gx is equal to 9 upon x plus 2, fgx. So fgx would be function of gx substituted in f, 6 minus, this should be 9 upon x plus 2, right? So can we say that f gx is basically 5? So let's just substitute this with 5. This is going to be 6x plus 2 minus 9. LCM is x plus 2. So 5x plus 10 is going to be 6x plus 12 minus 9. So this should be 5x minus 6x, 3, and this should be minus 10, which means minus x is equal to minus 7. Minus minus is cancelled. You're left with x is equal to 7. There's another example which says fx is equal to 2x minus 5. Gx is equal to 4 upon 2 minus x. Find the value of x when fgx is equal to 7. So what do we do? Fgx. So in the function of fx, we need to substitute what? 4 upon 2 minus x. Right? Then we write down minus 5. Because gx is substituted in the function of fx. But on the other hand, we know that fgx is 7. So this is going to be 8 minus 5, 2 minus x. Obviously, we're going to take LCM of 2 minus x. So 7 2s will be 14 minus 7x is equal to 8 minus 10 plus 5x. So we have minus 7x minus 5x, which means we are left with minus 2. Since 14 will go there, it will become negative 14. So this should be negative 12x is equal to negative 16. Negative, negative cancel. Value of x is 4 upon 3. So normally, your composite function will always have situations where you need to substitute the values with the value given so that you can solve the composite functions. Now, in this same topic, you should be well aware about quadratics as well. Now, quadratic is completely a different topic in your syllabus, but what you need to understand is that quadratic is that somehow linked to functions. So, like, for suppose quadratics. Your quadratic equation is normally in the form of ax squared plus bx plus c. Your quadratic equation is in the form of ax squared plus bx plus c. So you should be knowing this, that the quadratic equation is somehow compared to completing the square form, which is a x minus h whole square plus k. Now, these both forms have their own importance. Now, let's say that ax squared plus bx plus c can be changed to a x minus h whole square plus k. But what does quadratic equation do? Quadratic equation initially tells me that if a is greater than 0, so the curve will be a U-shaped curve. That means if a is positive, you will always have a U-shaped curve. If a is less than 0, it will be an N-shaped curve. It will be a N-shaped curve. Similarly, even the completing the square form value has the same thing, that a is greater than 0, it is a U-shaped curve, less than 0, it is a N-shaped curve. Your quadratics, when x is equal to 0, it shows y-intercept. It shows y-intercept. That means in the same question, if this is x and this is y, the intersection of the curve is shown by value c when x is equal to 0. So similarly, your completing the square form gives me turning point of the curve. That means that turning point can particularly be maximum if it is an N-shaped curve. It can be minimum if it is a U-shaped curve. But turning point is generally that comes from H comma K. Turning point generally comes from H comma K. So when I'm drawing the graph through quadratic, I know the y-intercept, but y-intercept comes from the ax square plus bx plus c. But when we talk about the turning point, it comes through ax minus h whole square plus k, because turning point is particularly h comma k in the completing the square form, whereas c is the y-intercept. Y-intercept when x is equal to 0. Now, you need to understand this, that you're completing the square form and the quadratic can be shifted. Can be shifted using comparing method. Like for suppose if we say ax square plus bx plus c, if it is shifted from ax minus h whole square plus k. So that means we open this ax square plus bx plus c. This generally can be opened as so can we just open this that a, this should be x square minus 2xh plus h square plus k. That means when we opened up the entire equation, this is equation is opened as x square minus 2xh plus h square. This is opened through the identity of a square minus 2ab plus b square. Now let's just compare this, that a x square plus bx plus c can be compared to ax square minus 2axh plus ah square plus k. Now, when we use comparing method, we know that ax square is compared to ax square. Then we know that bx can be compared to minus 2axh. And if we say this c can be compared to ah square plus k, because x square will be compared to x square, your x will be compared to x, and your constant will be compared to constant only. So knowing this, we can always write this thing down as ax square is compared to ax square. Your bx can be compared to 2 minus 2axh, and your c can be compared to ah square plus k. To find the value of a, h, and k, let's just do an example. The example that we can directly relate to is x square plus 5x plus 8 equivalent to x plus p whole square plus q. Now we know that this is your quadratic, and this form is completing form. Now, the question might arise that in your mind that the form that we spoke about was ax minus h whole square plus k. So generally in the past papers, when the examiner will test you, the examiner will test you through different forms of completing the square, which means the examiner can test you through ABC, the examiner can test you through PQ, the examiner can test you through CD, or the original form, that is ax minus h whole square plus k. So let's just work out through the given example question, that is x squared plus 5x plus 8. And if we just open this, this would be x plus p whole square plus q. We need to open up. So let's just work out with the same example. This is x squared plus 5x plus 8. If we just open this, this should be x squared plus 2xp plus p squared plus q. Now, we know this x square is just generalized. We don't have any variable, so it's just fine. Just write it down. Or even if you don't write it, it's completely all right. So the other is 5x, because x is here, the other x I can find is here. So this should be compared to 2xp. X and x is cancelled. 5 upon 2 should be p. Whereas we have 8 as constant, this 8 should be compared to p square plus q. 8, we know that p value is 5 upon 2 whole square, whereas q is given. So 8 is equal to 25 upon 4 plus q. 8 goes on the other, minus 25 upon 4 goes on the other side, q remains here. There should be 32 minus 25 when taking the LCM. 32 minus 25 will be 7 upon 4. So q value is 7 upon 4. The question had x plus p whole square. The question had x plus p whole square plus q. So the equation would be x plus 5 upon 2 whole square, and q should be 7 upon 4. Now, as I said that the question was x square plus 5x plus 8. And this is x plus 5 upon 2 whole square plus 7 upon 4. Now, from the quadratics, you know that this 8 is C. So this gives me y-intercept. This gives me y-intercept of the curve. This 5 upon 2 and 7 upon 4 will be the turning point. But turning point, here's the situation. Your x sign will change. This should be 5 upon 2 negative, whereas 7 upon 4 will be same as it is. If it was negative, it should be written as negative. If it is positive, it will be positive. But the sign of the x is changed because your original form had a x minus h whole square plus k. So if we just compare to x plus 5 upon 2 whole square plus 7 upon 4, so you must notice the sign change. So if the sign change from negative to positive is there, so that means the value, if it was negative initially, that means the value of 5 upon 2 should have been negative as well. Because of the 2 negative, the sign has changed. So that means this one is the original sign, but this negative is with what? Minus 5 upon 2. And just because of this negative, the sign has changed, which is x plus 5 upon 2. So when we write down the value of the turning point, we write down as negative 5 upon 2, or stating it as sign is changed. Stating it as sign is changed. So when we do quadratics, we work out through what? We work out through the y-intercept. Your y-intercept gives is through the quadratic equation, which was 8 in this example, and the turning point is minus 5 upon 2. So since we know that we have x plus 5 upon 2 plus 7 upon 4, and we got to know that the turning point is minus 5 upon 2 comma 7 upon 4. Now this minus 5 upon 2 is basically representing x, and 7 upon 4 is representing y of the turning point. We know this 8 is basically the y-intercept. This 8 is basically the y-intercept. And the curve is the curve, since both your a x squared plus b x plus c, a is greater than 0. So the curve should be what? In the U shape. The curve should be in U shape. So let's just draw this. We know it's a negative x and positive 7 upon 4. So your x-axis, your y-axis, and let's draw your x-axis. Normally the questions come through what? The question says sketch. So what does that sketch mean? That sketch means that you just need to draw. You just need to draw through the given points. So this is negative, the positive x-axis is always on the right. Anyway, so we have negative 5 upon 2. So let's say we have negative 5 upon 2 here. And let's say 7 upon 4 is somewhere here. So this would be your turning point, right? Your y-intercept is 8. So let's just write it down as 8. So when we'll draw the graph coming directly, and it will intercept what? It will intercept the y-axis, and it will turn through what? It will turn through the turning point. This will be your turning point, and this turning point is basically your minimum point. This turning point is your minimum point. This 8 becomes your y-intercept. This 8 becomes your y-intercept. Now, generally, the question that comes is with the respect to domain. Domain is values of x. Your values of x are basically written as, or normally the question says as domain. So x is element of all the real number. That means any value of x can be taken into consideration. For any value of x to be taken into consideration, your range, now your range are the values of y. Your range will be fx. Now y will be shown as fx. Now the entire value is basically, if you see that all the values will be above this point. All the values of y will be above this point. So when it is above the point, so that means all the values of y will be greater than equal to 7 upon 4, because this point is included, right? So the function for range, the domain is x is all the element of all the real number. That means any value on the right, any value on the left. That means range value of y can be 7 upon 4, because all the values will be above 7 upon 4. No value will go below 7 upon 4. So that means the values will be above 7 upon 4. So we write this thing down as fx greater than equal to 7 upon 4. So in the question, when the question generally asks us the domain is the value of x. So the domain is mostly given in the question. in the question, right? So, whereas range to be found out, range to be found out. Now, this range is applicable for when the question says X is element of all the real numbers, or generalized form when the question gives me set of values as inequality. It could be greater than A or it can be less than A. So in these particular points, we'll be writing fx greater than equal to your value, let's take y value as b, or less than your value of b. That means if the generalized form, that means the graph, your a is greater than 0, it should be greater than, this will be for a is less than 0, because it will be a u-shaped curve and this should be a n-shaped curve. So we normally did composite functions, then we started off with quadratics and the completing the square form, so that we move down towards the graph and the range part, because this will connect to the inverse and the one-to-one function questions of function that are asked by the examiner. So that's about it from lecture number 1.